Hi and good evening. So we are from group 2 and today we will explain our group assignment question number 2. So which is fx equal to 2x squared over x squared minus 1. So first we will introduce ourselves first. My name is Boon Seng Hong.
My name is Yang Guo Hong.
My name is Rejek Boljoni.
My name is Muhammad Alif bin Muhammad Jamaluddin.
My name is Yan Xingyi. My name is Ong Sufan.
Okay, so first Alif will explain first.
First of all, we want to find the domain. To find the domain, we take the denominator x squared minus 1 equal to 0, and then minus 1
Move to the
move to the right, and then x equal to plus minus 1. So the domain is all the real number except one except 1 x equal to plus minus 1. So and then second, we want to show you we want to find the range. To find the range, we let y equal to fx y equal to f inverse function. So first, x equal to 2y power of 2 over y power of 2 minus 1, and then the y power of 2 minus 1 move to the left, then times times with x, and then equal to 2 power of 2 2y power of 2, and then we solve until we get y equal to square x over x plus 2, and then the range of the function is all the real number for y greater than 2.
Okay.
We find the x and y intercept. First we let the fx equal to 0, and then the question we let fx equal to 0, and then we find the value of x equal to 0. The intercept of the function is the 0, and then we find the y-intercept when we declare the x equal to 0, and then the value of y-intercept is y equal to 0.
So next we will find the asymptote. First we find the vertical asymptote. So we do like this: x plus 1, x minus 1. So we can see that x is equal to negative 1 and 1. And from the definitions of asymptotes, which is, as we can see here, as limit x approaches 1 from the right, fx approaches infinity, and limit x approaches 1 from the left, fx approaches negative infinity. This is same for the negative one, which is limit fx approaches x from the right, it's equal to infinity, and limit fx x approaches to negative 1 from the left is equal to negative infinity. So from these definitions, we can see that the vertical asymptotes is x equal to negative 1 and x equal to negative 1. Next, we find the horizontal asymptotes. So from the definition of horizontal asymptotes, we can see that as 2x squared over x squared minus 1, as x approaches infinity, it approaches 2. So the horizontal asymptote is y is equal to 2.
So next we will find the critical points and identify the intervals on which the function is decreasing or increasing. So first we need to use first derivative method to find out the f prime x first. So the equation given is fx equal to 2x squared over x plus 1 x minus 1. So let 2x squared equal to u and this one equal to v. So to find the f prime x, we use the product rules and put the equation into the product rules. Is like x squared minus 1 times 4x minus 2x squared times 2x over x squared minus 1 square. So after we calculate, we will get 4x cubed minus 4x minus 4x cubed. So this one cancel out, will be left minus 4x at the above, and then the below one is x2 minus x squared minus 1 square. So this will be the f prime x of dy dx of the function minus 4x over x squared minus 1 square.
To find the critical point, we know that the first condition is let f prime x equal to 0. So, and we get the answer is x equal to 0. And the second condition is when the f prime x does not exist. So we can get the answer is when x equal to 1 and when x equal to negative 1, the function f prime x does not exist. So the conclusion, the critical points are x equal to 0, x equal to 1, and x equal to negative 1. But x equal to negative 1 and negative 1 is not critical point because both of the x values are not in the range of in the domain of our functions. But we still can use the x equal to negative 1 and 1 to separate our interval to find the increasing and decreasing of our function. So we put the value in from negative inverted to negative 1, we put the test value, and we found the behavior of function is increasing, and the next one is negative 1 and 0. We put negative 0.5 and the function is increasing, and 0 to 1 the function is decreasing, and finally 1 to infinity the function is decreasing.
So we're going to explain the second derivative test. So first, to find the second derivative test, we use the product rules. So we find u dx, v dv dx, and then we get the answer for 3x squared plus 1x squared minus 1 cubed. And we find the second derivative. After we find the second derivative, we know that to know that we need to find f prime x equals to 0, and the other conditions is f prime x does not exist. First, the f prime x equals to 0 is v equals it to 0 and x equals to 0, and does not exist is x equals to 1, x equals to negative 1. So x plus minus 1 is not inflection point since it is not in the domain.
Okay, so to test the concavity, we put in the test value in between the range to test whether the second derivative is positive or negative. So for the range of negative infinity to negative 1, we put in the test value of negative 2, and the result is positive, is the concave upward. And then for negative 1 to 0 and 0 to negative 0 to 1, the second derivative is shown negative, so it is concave downward. And then for 1 to infinity, the second derivative is positive, which is a concave upward. And then we will find the local max or the mean values. So we let the first derivative equal to 0, and we find the turning point 0, 0, 0 are the stationary point. And then we test the second derivative. When x equal to 0, we find that it is equal to negative 4, means it is a local max point. So the 0, 0 is a local max point.
Okay, after we find all the result for asymptote and horizontal and vertical asymptote, the maximum value and the everything we need. Now let's come to the drawing part, which is the sketching for the graph. Okay, first of all, we need to draw the asymptote and the x and y axis. So from the result, we know that from negative 1 to 1, the concavity is upward, and from negative 1 to 0, the concavity is downward. And know that the graph won't touch the asymptote because it is asymptote. For the horizontal asymptote also, y is equal to 2. So this is the graph we need from the result. That's all for me.